Okay, so for unit 7, we're asked to divide. This one will have a remainder, the one on your test won't. Okay, so I'm going to set up for long division. X minus 2, 2x to the 4th, plus 0x cubed, because there's no cube term, minus 5x squared, plus 0x, because there's no x term, minus 3. Okay, then I divide. So I take this one, divide by this one, and I get 2x cubed. And then I distribute it to both. So 2x to the 4th minus, that's going to give me negative 2x cubed. But then I have to distribute my negative. I do like to use a second color to emphasize that. So this will end up with being a positive 2x cubed minus 5x squared. So I would multiply that by a positive 2x squared. When I distribute, I get a 2x squared minus 4x, cubed, 4x squared. Distribute your negative, and I get a negative x squared. I'm just going to put that right up here. Negative x squared plus 0x, so I'd go a negative x here. That would give me a negative x and a negative positive 2x. But when I distribute that negative, I get a negative 2x here and a minus 3. So I know I'm going to do a negative 2 here. Negative 2 times x is negative 2x. Negative 2 times negative 2 is 4. Okay, I think I had a different remainder here before. Let's see, I'm getting negative 7, but I thought I had a different answer last year, so I wonder if I made a mistake. Unit 7, yeah, before I got a 9, so let's see, where did I go wrong? I put a 4 there. Let's see, 2, oh, did I forget to multiply my 2 times 2? I did! Okay, so I totally made a mistake here. My 2 times 2 is a 4. Okay, so that's going to need to be a 4. So a lot of my numbers are going to change. I do apologize. Okay. Okay, so let's see here. So 2x cubed times negative 2x is negative 4x. But then when I subtract, dang it, I will get positive 4. Okay, so this is going to be a positive 4x cubed here. Good, so that means I need to do a 4x squared here. And so then I'll get a 4x and a negative 8x squared. But then this one's still a negative 5. I don't know how I did that one. So then when I subtract the negative, I get a positive, which is going to give me a positive 3x squared here. So I'll do a positive 3 there. 3 times 3. 3 times that negative 6. But then when I distribute that negative, I'm going to end up with a 6x. And so I'm going to get a plus 6 here. 6 times x is 6x. 6 times negative 2 is negative 12. And then when I subtract a negative 12, it'll be adding a 12, and 12 and negative 3 make 9. Okay, so it'll be a 9 there. So that 9 is going to be my remainder. So how you'll write your final answer is 2x cubed plus 4x squared plus 3x plus 6 plus, you take that remainder and you divide it by your divisor. The one on the final won't have a remainder, so don't worry if that part is hard to remember. Okay, next one here, we are going to do division again. We have our x minus 4 out here, negative 2x cubed plus 3 squared plus 23x minus 12. Okay, and so when I do that, I'm going to have a negative 2x squared. It's negative 2x cubed, positive 8x squared minus, that'll be a negative 5x squared plus 23x. Now multiply that by negative 5x. So negative 5x times x is a negative 5x squared. Negative 5 times positive 4, positive 20x, but we're going to distribute that negative. So I'll have a 3x and a negative 12. Okay, so this will be a positive 3. 3 times x is 3x. 3 times negative 4 is negative 12. And when you subtract, bam, you get 0. So now I'm going to factor that trinomial there because it says to give the complete factorization. Okay, so I'm going to factor that negative out. Okay, I know I'm going to have my x minus 4. So if I factor the negative out, I have negative 2x squared plus 5x minus 3. And so then I would go, one needs to be a 2x, the other needs to be an x. Two things that multiply to be 3 are 1 and 3. I want to put my 3 here because 2 times 3 is 6. And then if I take away 1, I get 5. So I want this to be my positive, this to be my negative. Minus 1, x plus 3. So my zeros are 4 from this one, negative 3 from that one, and then this one you set it equal to 0. So if you add 1, you get 2x equals 1, divide by 2. You're getting 1/2. Okay, next one, I'm going to find my HK. That's 1, 3. 1, 3 is here. It's an open circle. It's a negative, which means I'm going to go down. So I go right 1, down my stretch, which is 1. Okay, remember you're going to have these asymptotes here. This is an odd one, which means it looks like this unless it's negative, then you go down. So I go left 1 up 1, and I get this graph here. Okay, my domain is negative infinity to infinity. My vertical asymptote is x equals 1. My horizontal asymptote is y equals 3. Okay, good. And if you really wanted to think about it, you could think about it as, okay, negative 1 over, you're plugging in numbers for x. So you can plug in a 1, but you get negative 1 over 1 cubed. That's going to be a negative 1 over 1, which is 1. So that's how I'm going left 1 up 1 for the first one. And then I go negative, and I go negative 1 here. Okay, or sorry, it was 1, and then down 1. Sorry, so right 1 for that one, down 1 for the negative. And then here, if you plug in a negative 3 cubed is negative 1, times negative divided by 1 is negative 1. Times negative is positive 1. So that's why you would go left 1 for this negative and then up for that one. Okay, this one's very similar. My HK is negative 3, 0. Okay, so my vertical asymptote is x equals negative 3. My horizontal is y equals 0. This time I'm going to go right 1 up 5. 1, 2, 3, 4, 5. And I'm going to go left 1 up 5. Okay, giving me a range of 0 to positive infinity. Okay, and again, I know this because it's 5 over x squared, so if I do my negative 1 squared, that's 5 over 1, because negative 1 squared is 1, so it's just 5. So that's why I'm going left 1 up 5. 5 over 1 squared is also going to equal 5, and that's why I'm going right 1 up 5. Okay, good, good, good. Okay. You guys can keep talking to me though. Okay, so I'm going to do this graph here. You may have already started it when the video went out. Okay, so when we are working on an equation like this one, I can see there's x in the numerator, x in the denominator. It's going to be a rational function with asymptotes. To find those asymptotes that are vertical, you factor your denominator. And so that'll be x plus 2, x minus 2. I do not know. 74. I don't know that would be it. 74 is pretty set, I'd say. X squared. So if I set each one of these equal to 0, I'll get my 2. You could come in and do some target retakes to bring up your grade before the final. I mean the target retakes from your test, the formal target retakes. Those you have to come in at lunch, and I guide you through it. And it actually helps you do better on the final too. So then I'm going to plot those asymptotes here. X is 2, x is negative 2. Okay, my horizontal asymptote comes from taking those two and doing a partial division. So I'm going to go x squared divided by x squared, that's 1. So I'm going to get a horizontal asymptote of y equals 1. There are no slant asymptotes on the final, FYI, so you won't have to worry about that. Okay, if you find your y-intercept, you can find a point on your graph. So to find your y-intercept, you plug in x with 0. Put a 0 there. So I'm going to go y equals 0 squared over 0 minus 4. That's 0 divided by 0 or 0. So put that point right there. Okay, so now how does this behavior go? I'm going to pick some numbers from my graph. I need a number to the extreme left to see if it's above or below my asymptote. So I'm going to plug in a number like negative 1,000. I need one over here as well, so I'm going to plug in positive 1,000. I need values from the left and right of my asymptote. So on this one, I'm going to do negative 1.999, and on this side here, I'm going to do negative 2.001. For this side here, I'm going to do a positive 1.999, and for this side here, I'll do a positive 2.001. Now, one of the things I noticed right away is that when I square a negative or I square a positive, it's going to be a positive. So I really only need to check the negatives or the positives because those answers are going to be the same when I square them. Okay, so let's plug in that 1,000. So I go 1,000 squared. Uh-oh, I should put parentheses just for good habit. And then 1,000 squared minus 4. And here I get 1.004. Okay, so when I look at that, my f of 1,000, 1, 2, 3. And that could be positive or negative because I'll get the same answer, 1.000. That's just above my asymptotes at both locations. Okay, now I'm going to plug in the 2.001. I'm going to use the same one over again. 2.00. Insert 1. 2.00. Uh-oh. Dang it. Didn't mean to do that. The wrong button. 2.00. 1. Uh-oh. Still need my little parenthesis there. Okay, good.
I should have done all that's just a solid diamond. That's cool.
2.00. So I'm going to insert 1. Okay, and I get 1,000, which is huge. So I write that down. F of x plus or minus 2.001 equals 1,000-ish, approximately. So that means it's going to be going way up here. Okay, that shows that I won't be going through that asymptote like that and like that. Usually we don't have up here. It's probably going to be downward this way. Let's double check that. So I'm going to plug in f of plus or minus 1.999.
Oh my god, we got all the juniors attending. It was just so much.
And I get negative 999. So that means that from here it'll go downward because it's the same. It'll go downward. I'm going to go up to that asymptote, or up to that intercept and then back down. Excellent. Okay, for this one I'm going to factor my denominator. So I'm going to have x plus 2 over x minus 5 times x plus 2. When I reduce, I end up with a 1 over an x minus 5. That tells me that I'm going to have a hole here. Okay, because I reduced it out. So you take that value here, x plus 2, set it equal to 0. And we get x equals negative 2. So that means at this point where x is negative 2, there'll be a gap in our graph. So I'm going to plug it back into my reduced equation. Plug into reduced. Okay, so that'd be 1 over negative 2 minus 5. And that would give me a 1 over negative 7. So that would be negative 2 comma negative 1 over 7. Means I'm going to have a hole about right there or so. Okay. Now let's do my asymptotes. This one I'm going to have a vertical asymptote at x equals 5. 1, 2, 3, 4, 5. Okay. My horizontal asymptote will be at 0 because I would take that 1 divided by 1. Okay. Or 0x divided by x. So my y equals 0, x divided by x, and that equals 0. Okay. You can now just use that same pattern from the odds, or what you learned in Math 3, or you can check your behaviors. If you're going to check your behaviors, you're going to put in negative 1,000, positive 1,000. Okay, and you're going to plug in 4.999 and 5.001. Okay, so I'm going to go 1 over negative 1,000. I'm not squaring it, that's why I didn't put it in parentheses. Okay, minus 5. I can see that that's going to be a negative number, which means it's below. If I plug in 1,000, 1,000 minus 5 is a positive number, so I'll still have a positive number, so that'll be above. Okay, if I plug in 5.001 and I subtract 5, it'll be like 0.001, and 1 divided by 0.001, let's try that out. 1 divided by is 1,000, so that means this one's going to go way up. Okay, and then here I'm plugging in my, let's go down here, 1 over 4.999. It's going to end up giving me a negative, which doesn't quite make sense. Oh, that hole is down here. Gosh darn it. I'll have to wipe that out. Okay, because it was negative 1,7. Okay, minus 5. That's negative 1,000. Let's make this one a little prettier too. Okay, so I'm going to wipe that out. I'll do that later. Okay, let's see. And I don't really need all of that, but I'll leave it. Okay. Next one, number 9. This one is an x squared graph, so it'll be y equals a over x minus h squared. I know that it's the square because it's going up, up, plus k. So I can see my hk here, right in between my asymptotes. So that would be an hk of, let's see, that is negative 3 comma 0. So I plug in my negative 3 there and my 0 there. Equals, oh, I can also see my stretch. It's going to go right one, up one. So my a is 1. So when I plug that in, I will have 1 over h minus negative 3, so that'd be x plus 3. And then that would be squared, and then my k value is 0, so I can leave that off. That's kind of in my way. Okay, good. Okay, just a couple more. Number 11 is our difference quotient. The one on the test is a more simple version of this, but I'm going to take this and plug it in there. So I'm going to have 1 over h plus 5 minus 9. And then I'm going to plug in the 5 where the x goes. Minus 9, and that's all over h. So I'll simplify that. That's 1 over h minus 4 minus 1 over negative 4. That would be a negative, negative makes a positive. Okay. And so now I'm going to, this is all over h. So I did the fraction buster to clear the fraction. So I multiplied everything by the GCF of all of those combined. This one, the denominator is actually 1. So I'll do multiply by h minus 4 times 4, h minus 4 times 4, and h minus 4 times 4. Okay, so here, those will cancel, those will cancel, and nothing here will cancel. So I'll end up with 4 times 1 is 4, plus 1 times that, which will be h minus 4. Okay, all over 4h times h minus 4. If done correctly, something should cancel. You'll end up with h over 4h times h minus 4. Those h's will cancel, giving you a final answer of 1 over 4 times h minus 4, where h does not equal 0. Okay. One last, nope, I guess I have 2 last ones here. Okay, so I'm going to do some long division here. My h minus 3, x cubed minus 2x squared, plus 0x. Hey, Hanson. All right, sounds good. Okay, I'm going to divide. I get x squared. All right, I'll be there a little bit before 7. Okay, so when I multiply, I get x cubed minus 3x squared, but then I have to distribute that negative. So that'll be x squared plus 0x. So now I need to do x times x is x squared. So x times negative 3 is negative 3x. Minus minus. So that's going to be a 3x minus 9. And so I know that I needed 3 there, so plus 3. And then my plus 3, I'll multiply, I'll get 3x minus 9. But when I distribute that negative, everything cancels. So that's how I'm getting E as my final solution there. Okay, one more, I'm going to do number 14. And number 14, I can see that this one is an odd function, but all of those are too. I can see that I have asymptotes here. right away my horizontal asymptotes all match, and that's because here I have y equals 1, and so 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. So I can't get rid of any based on my horizontal asymptote. Let's look at this one here. This is an asymptote of x equals -3. So that means that I'm going to have an x plus 3 in my denominator. So I can get rid of that one, that one, and that one. It's going to be between these two. Oh, and guess what? Those two are exactly the same. What a bummer. Guess it doesn't matter which one you pick because I didn't put anything different on there. So I'm going to say B or D. On the final, there's only going to be one answer. Hopefully I have all my typos worked out. Awesome.